Hello students, in this video we will be discussing about frequency modulation. See one basic problem on this. Of course, this is a previous IES examination question in 2014. The message signal m of t equal to sync 2 into 10 power 4t is frequency modulated with K means Kf is 10 power 3 Hz per volt. What is the maximum instantaneous frequency of modulated signal when carrier frequency is 1 MHz? When carrier frequency is 1 MHz. What they are asking maximum instantaneous frequency means he is asking F max. What is the formula we know? Fc plus Kf into m of t. M of t means you need to take here m of t max value you need to take because F max I am taking. What is the FCs are? 1 mega. 1 mega means I can say 1000 kilo plus Kf value 10 power 3. So 1 kilo into, for the sync function, what is the maximum value? Nothing is mentioned means here 1. So its maximum value also 1. Then 1001 means 1.001. I can say megahertz. This is about what? F max. And this is what? Delta F. And if you want to calculate, of course not asking, if you want to calculate F minimum formula, Fc minus Kf into m of t value, of course m of t is max. What is the maximum value of m of t? You can see there 1. So Fc minus this value is 1. 1000 minus Kf value 1 kilo. So 999k or 0.99k, 99 mega or 999 kilo. Delta F is 1 kilo. If you want the total frequency swing, 2 delta F value is 2k. One more simple problem. This is also previous IES examination problem. The carrier frequency of FM signal is given by 2 MHz. The total frequency swing is 800k. Then calculate delta F, F max, F minimum. What they are giving? Total frequency swing means they given 2 delta F value is 800k. Then delta F value is 400k. One thing is done. Next is asking F max. What is the F max value? Fc plus delta F. What is the Fc value given? 2 mega plus delta F. Delta F means 400k. So 2400k I can write. Now what is F minimum, sir? Fc minus delta F. 2 mega minus 400k. That will be 1600k. Fc plus delta F, Fc minus delta F. Just on the base problems. See the problem. A 20 volt, 2 megahertz carrier is frequency modulated by a modulating signal of modulating or message, both are same. 5 volt, 15 kilohertz. The frequency sensitivity means Kf is given by 30 kilohertz per volt. Then calculate. First question, delta F, beta, bandwidth, power requirement. Second problem, repeat the above if message signal amplitude is double. Are you following my point or not? See the first problem. What is delta F? Delta F is Kf AM. What is the Kf value given? 30. What is the AM value given? Amplitude of message. This is the message amplitude frequency. This is the carrier amplitude frequency. Then how much you will get? 150 kilohertz. Per volt cancel, H remaining. Next, what we need to calculate? Beta. What is the beta? Beta is nothing but delta F by Fm. Delta F just now we got 150 by Fm. Fm is 15. Calculate how much you will get? 10. Beta no units, it's a unitless quantity, modulation index. Are you following my point or not? Next. After beta, bandwidth. Greater than 1, beta what we got? Greater than 1 means wideband FM. Bandwidth formula 2 times beta plus 1 into FM. That is 2 times beta is 10 plus 1 into FM. What is the FM value? 15. So 15 into 2, 30 into 11. Are you getting my point or not? 30 into 11 means I think 330 kilo. Got my point? Next, power. For wideband FM, what is the power? Power is AC square by 2R. AC value given 20. Resistance is not mentioned 1. 400 by 2, 200 watts. Getting my point or not? Now what they are asking in the second problem? In the second problem, they are asking, repeat the above if message signal amplitude is double. Now see what I am doing. Here itself I am following. New value delta F dash. Amplitude of message AM is double. If AM is double, obviously delta F also will double. What is the previous value? 150. Now you will get 300. Apart from the values, the most important point you need to understand, if AM, that is message signal amplitude, is double, delta F, maximum frequency deviation, also double. Next, beta, new value beta dash. Here delta F is doubled, already we seen. No changes in FM. He doesn't say anything on FM. Delta F is double means obviously beta also double. Previously 10, now it will be 20. So you need to understand modulation index also double. Come to bandwidth, whether doubled or not. Here beta value now how much? 20. So 15 twos are 30 into 21. Are you getting my point? Then how much it will be? New value bandwidth dash will be 30 into 21. So 600, 630. Double means actually it has to come 660, but you got 630 only. Means bandwidth increases but not doubled. Come to the power requirement. Here any AM is there? No. Only it's depending upon AC. If AM changes or even FM changes also, no change in the power. So I can say PT dash is also equal to PT only. Only the point you need to understand from this problem, if message signal amplitude is double, then maximum frequency deviation and modulation index both are double. Bandwidth is increases but not double, but no change in the power requirement. See the next problem. A frequency modulated signal is given by S of t equal to 10 cos 2 pi into 10 power 60 plus 5 sine 2 pi into 10 cube t. Then calculate first question delta F, comma beta, bandwidth and power requirement. Second question, repeat the above if message signal frequency double. I understand my point. Now, if you see this expression, this is the singleton FM expression they given. Singleton FM expression, expression number 12. Singleton. Compare with that singleton expression. What is singleton FM expression? S of t equal to AC cos 2 pi FCT plus beta sin 2 pi FMT. So, this 10 is nothing but AC and this is FC. This is modulation index beta. This is FM. Now, see the solution. First, what we need to calculate? Delta F. Formula KF AM. No KF, no AM given. Another version is, you can see, beta is directly came 5. Beta formula is delta F by FM. So, then delta F will be beta FM. Beta value is 5. FM is given 1K. See the problem. So, it is a 5 kilo. Beta value already came 5. Greater than 1 means wideband FM. Then what about the bandwidth? Bandwidth is nothing but twice and twice beta plus 1 into FM. So beta value how much? 5. FM value 1K. 6 2s are 12. 12K. What about the power requirement? PT. AC square by 2R. AC value how much? 10 cos means 10 square by 2 into resistance is not given means 1 ohm. 100 by 2 which is nothing but 50 watts. That is the first problem. Just comparing with the standard expression of AM. Sorry, standard expression of FM. That is the expression number 12. What is SFM of T equal to? AC cos 2 pi FCT plus beta sine 2 pi FMT. What is the second problem they are saying? Repeat, if message signal frequency double, FM is double, then what? Are you getting my point? Follow. Means previously 1K, because this omega divided by 2 pi. Previously 1K, now double means 2K. Follow. New value delta F dash, KF dash, AM dash. No change in KF, no change in AM, so no change in delta F. What is the previous value? 5K. Now also 5K. Got my point? Will you satisfy for that? Some of the students will have the doubt, sir. Beta FM na. FM is now doubled, so 2K. So 5 to sir 10K. They will ask like that. But in the second case, can you guarantee beta value is 5 only here also? No. Why? Because beta is directly proportional to 1 by FM. If the modifications in the FM, then beta also varies. You can see. So new value of beta dash means here delta F no change, but FM is double. So it's 1 by 2 of previous value that you will get as a 2.5. Yes. Now you can keep 2.5 into 2K. Still you will get a 5K only. Are you understand my point? Second case, beta is changing, so you cannot substitute the previous value. So what you understand from here? FM changes, means message signal frequency changes, means double. There is no change in delta F, but modulation index is becoming off. What about the bandwidth? New value is nothing but 2 into, what is the new value of beta? 2.5 plus 1, 3.5 into, what is the FM? 2K. 3.5 into 2, 7 into 2, 14. So 14K. Bandwidth is increases, but not doubled, but not offed. What about the power requirement? PD dash, obviously it will be same as the previous value because there is no relation with the FM. So final conclusions, what we need to learn from this problem? If message signal frequency double, no change in delta F, modulation index is reduced to off, no changes in the power requirement. A carrier is frequency modulated by a sinusoidal signal and the frequency deviation is 8K. Message signal frequency is 2K, then calculate. First question, modulation index beta, comma bandwidth. Second question, repeat the above. If the amplitude is increased by a factor 3, frequency reduced to 1K of a message signal. First to the first problem. So what is the first problem? Calculate modulation index. What is the modulation index formula? KFAM by FM, which is nothing but delta F by FM. What is delta F is given? Frequency deviation 8K. Message signal frequency 2K, then it will be 4. 4 means greater than 1. Greater than 1 means, students, wideband FM. For wideband FM, what is the bandwidth formula? Bandwidth is nothing but 2 times beta plus 1 into FM. This you have to keep in your mind. and all the basic problems I am solving, and all the gate problems in the last I am giving you. Follow. What is the beta? 4. 4 plus 1, 5. 5 2s are 10. What is the FM? 2K. 10 2s are 20. What is the second problem? Is saying that repeat the above problem, amplitude increased by a 3 factor. If amplitude is increased by 3 factor, what is the new value of delta dash? Delta f dash, it is also 3 times. FM changing also no effect here. Calculate the new beta value, that is 3 delta f, previous value 8K. Now FM is decreased to 1K. Then what is this value? 24. Then what is the new value of bandwidth? Which is nothing but 2 into beta. Of course, no beta value is 24 plus 1. FM is 1K. 25 2s are 50K. Here all the logic is amplitude is increasing means delta F is increasing. No changes with the FM. We seen in the previous problem also. Anyhow, beta will change with that FM. So I written that. Next, this is the problem on the frequency modulation. Phase modulation. A phase modulated signal is given by S of t equal to 10 cos 2 pi into 10 power 6 t plus 5 cos 2 pi into 10 cube t. Is then calculate first question delta f, beta p, bandwidth and pt. Second problem, repeat the above if message signal frequency double. Here not delta f, here it will be delta phi. Maximum phase deviation. What is the maximum phase deviation, sir? Maximum phase deviation is, one second. Maximum value of Kp into m of t or Kpam for sinusoidal, and another logic here which is also equal to modulation index in phase modulation. See the expression. What is the general expression for FM? PM, expression number 17. What you got? AC cos 2 pi FCT plus beta means beta P cos 2 pi FMT. Try to compare. If we compare, what is this value? Is 5. Beta P also 5. 5 means greater than 1. So bandwidth is twice of beta P plus 1 into FM because wide band. Beta P value 5. 5 plus 1, 6. 6 2s are 12. Into what's the FM value? See there? 1K. So 12K. Next, power. For wide band, what is the power? Same formula. AC square by 2R. AC value given 10. 10 square by resistance not mentioned 1. So 50 watts. What is saying? Repeat the above if message signal frequency double. Are you getting my point? Frequency double means new value of FM, that is FM dash is 2FM, previously 1K, now 2K. You can see the formulas of delta phi as well as beta P, which is Kpam, no relation with the FM, so no variations of our maximum phase deviation as well as modulation index. But in frequency modulation, modulation index will be 1 by FM, directly proportional to 1 by FM, but here not. Let's see about the bandwidth. New bandwidth is nothing but 2 times beta P dash plus 1 into FM dash. This will be 2 times the beta P plus 1 because there is no change. But FM dash is 2 times FM. So 2 times previous value means what is the previous value? Previous value is 12. New value will be 24K. Means whenever message signal frequency is double, then bandwidth will be double. Understand my point or not? But in frequency modulation not happened, but in phase modulation it happened. In phase modulation, if message signal frequency double, bandwidth also double, no change in modulation index, no change in maximum phase deviation, delta phi. Their maximum frequency deviation will pronounce. See the next problem. This problem asking in the ESC examination 2017. An FM broadcasting radio station transmit signal frequency of 100 MHz with a power of 10 kilowatt. The bandwidth of a modulating signal is from 100 to 1.5 kHz. 100 to 1.5 kHz. If the deviation set by FCC, delta F is 75 kHz. This is standard value. The range of modulation index is. What is the modulation index formula? Modulation index formula is delta F by FM is called modulation index. Let's take delta F is 75K. What is the top value? 1.5K. How much you will get? 50 here. And to get another value, take another end of the FM, which is nothing but 100H. So this will be 750. So as message is varying from 100 to 1.5, it is also varies in between. So 50 to 750 means this question. Option C. Very simple problem. In IAS examination, all problems are not tough. Directly some of the direct questions will come. But they will give lot of theory, lot of data in the question to waste your time. So actually if you want to solve, how to solve is first to see directly what we need and directly substitute. No need of writing formula also, keep in mind and do. But for your understanding I am doing. Otherwise in the exam means directly 2 steps, 2 seconds it will be completed. If the frequency modulated signal with a single tone modulation has a frequency deviation of 15K. Frequency deviation of 15K, bandwidth is 50K. The frequency of the modulating signal will be modulating, message, information, intelligence, all are same. What is the bandwidth formula we have? Bandwidth equal to 2 times beta plus 1 into FM as well as 2 times delta F plus FM, also another formula. Beta is delta F by FM, FM you can multiply. What is this value is given? 50K. So bring the 2 this side, 25. What is delta F given? 15. 25 minus 15, then it will be 10. So FM is 10K. Very simple problem. You need to understand directly how to bring this formula. It should be in our mind. This is asking in the ESC 20 for 2 marks. This question. It's taking just a 10 seconds matter of accurately how to do. See the next problem. A carrier waveform AC cos omega ct, but here given 10 cos omega ct and a modulation signal 3 cos omega mt have FC 100K and FM 4K. Given that sensitivity of FM is 4 kHz per volt and FM spectrum beyond J6 is negligible. What are the channel bandwidth requirements for AM and FM? What is the bandwidth formula for AM? AM is simply 2FM. So what is FM given? 4K. 2FM means 8K. So AM bandwidth is 8K. And coming to the FM bandwidth, slight logic is there. Here you have to take beyond J6 negligible. So beta is approximately 6. 6 means 2 into beta plus 1 into FM. If you do, you will get some 56. No option is given. Another possibility is here. components beyond J6 is negligible. So I can say bandwidth equal to highest minus lowest. Highest is FC plus 6FM up to J6 minus lowest is FC minus 6FM. Upper sideband, lower sideband. Why I taken 6? Because after J6 is negligible. Then what is this comes? 12 FM. What is the FM value given? 4. 12 4s are 48. See how the logic we done now. So then option B. See the next problem. An FM signal has carrier swing of 100 kilo when modulating signal has a frequency of 8K. The modulation index is given carrier swing. What is a carrier swing means? 2 delta F. The value itself is 100K. Then obviously delta F will be 50K. Then modulation index is delta F by FM. Then it is 50K by 8K, which is nothing but 6.25. Direct problem. One of the engineering service examination problem in 14. See, all engineering services problems are almost direct and simple questions only. See the next problem. FM spectrum consists of carrier and infinite number of sideband components. Statement 2. FM signals are only used in TV transmission to ensure better picture quality. Options are both statements are correct. And the second is correct explanation for one. Option B, both the statements are correct, but the second is not correct explanation for one. Statement 1 is correct, 2 is wrong. 1 is wrong, 2 is correct. Like they given assertion and reason type of question. First statement, let's see individually both are correct or wrong. FM spectrum consists of carrier and infinite number of sidebands. True. Carrier component, infinite number of sideband. So that's why the bandwidth is infinite. I told it theoretically. Next, FM signals are used in TV not for the picture quality. FM signals we are using for audio content only. For picture, what we are using? VSBSC modulation, vestigial sideband. So directly option C. For example, if this is also correct, then the confusion will be there in A and B. Then what you have to do? In between you can keep but, then you can read. If it's looking like a meaningful one, go for A. Not meaningful one, go for B. But the point not came here because statement 2 is wrong. If they said audio quality, then I have to think. But he told picture. For picture, VSBC we are using. The minimum value of modulation index beta for an FM system required to produce a noticeable improvement in SNR or a comparable AM system with mu equal to 1 is options given 0.61524738. I already given SNR values when I given in the, that is the figure of merit, of course. SNR means figure of merit values. I given where in the waveforms I given. What is that figure of merit value? Figure of merit means output SNR by input SNR. That is nothing but mu square by 2 plus mu square. Mu given 1. So 1 by 3 means 0.33. What about for FM is 3 by 2 beta square. Now I have to take some minimum value of beta. You need to see improvement when compared to this. Are you getting my point? Let's do 3 by 2 means 1.5 into 0.38 square. If you do that, 0.2 will come. Means less than this, no improvement. Take the next option, 0.47. You will also get approximately 0.33, almost the same. So not a noticeable improvement. Next take B option, 0.52. Then you will get 0.4. So more than this 0.3, some improvement is there. He is asking about the minimum value itself. Anyhow, option A, if I take still I will get more. But it is a minimum Value is asking for the improvement, so option B.